Now let us write the Verilog code for this 4-bit shift register. Now module shift underscore register. Now what is the input here? The input is D in reset the clock. So I will say D reset, then clock, then output is Q. See, I am going to use the vector output because it's a 4-bit. Next, input D, comma, reset, clock, then output is, it's a 4-bit, so it's supposed to be 3:0 Q. Then register also supposed to be 3:0 Q. Now you tell me how to write here, how we can write. Always at passage clock begin. Okay, now how to write? I need to get the output. Each and every Q0, Q1, Q2. What will be the output of Q0 now? Then what will be the output of Q1? What will be the output of Q2? What is the output of Q3 now? Any answer? Nothing but, it is nothing but what? Q of 0. Yes. Next, Q of 2 will be what? It will be Q of 1. Next, Q of 3, that is last, will be Q of 2. Then finally, we can end. Then I can go for N module. See, first whatever I give D value, that I'll get in Q of 0. Then the Q of 0 will be shifted to Q of 1. Then Q of 1 will be shifted to Q of 2. Then Q of 2 will be shifted to Q of 3. So it's very simple. As you know, when D is equal to, when I give, I'm not given any value. When I apply reset is equal to 1, as per this, when I apply reset is equal to 1, initially what will happen? This all the values will be cleared. In the sense, your register will be clear, all the values will be 0. When I give reset is equal to 0, that is the meaning of this, else. Then automatically you will get a D value here. Irrespective of this here, what will happen? The Q0 will become as D actually. Correct. So example, I'll say if D is equal to, value is equal to 1, you think like this. Then what will happen? During the next edge of the clock, this will become as 1. This will become as 1. So I'll take this for better. This will become as 1. Next, during the next edge of the clock, what will happen? This will become as 1. Means this 1 will be shifted over there. What will happen? The next value, it is like I can say D sequentially value I'm getting like this. In the sense 0, 1, 0, 1. So first this value will be entered. Next this value will be entered. Next. So it is sequential in the sense serial in, serial out. It's not a serial in, serial out. Whichever the diagram I shown here, this is something but which concept? It is serial in, parallel out actually. Yes, we are taking the output in parallelly. If I take only the output here, then only I can say serial in, serial out actually. So now we return like this. Now instead of writing in this way, how can I write in a single line this one? Is there any idea? You can have any idea? Instead of writing these 4 lines, can I write any one single line for this? Very simple. How it can be written in the sense, as we know, the Verilog has one important special operator is there. What is that operator? It is a concatenation operator. You might have remembered. So Q is equal to, so here I am writing. Q is equal to, I'll open this one. So what will happen now? Q will be, each and every time the value will be shifted, right? Finally, last value will be what? Actually, so each and every time will be like it is a concatenation operator. The previous will be shifted over there. So even I can write, merge the values also. The Q will be what now? If I want to see the output each and every clock cycle, I can see also. Or during the first clock cycle, my output will be what? During the first clock cycle. During my first clock cycle, the output will be D, comma, 0, comma, 0, comma, 0. First clock cycle. Now, during the second clock cycle, what will be my Q actually? The D will be entered, correct? In this first. The D will be entered, in the sense new value. That is what I can say. So that new value will be entered, the D. Next will be what? Actually, will be D only. That is the previous value. That is Q of 1 or Q of 0. This is Q of 0. Next will be 0. Next will be 0. See, like this we may get. So I'll get totally 4-bit value. Even you can write like this also, or sometimes what they will do, they'll write like this only. This is one of the way you can write shift registers. The value will be shifted for each and every. So now you think here, after how many shift, I will get the entire value here. 4-bit shift register in the sense totally you need 4 clock cycles are required, because each and every shift will happen during the positive edge of the clock. So the positive edge of the clock will happen, only one bit will be shifted for 1 clock cycle. So totally 4 flip-flop is there. So totally 4 clock cycles are required here. So you can follow like this only better. This is the way. This is for 4-bit shift register. Next we will write the program for counter. Verilog code for binary counter. Binary counter, that is 4-bit binary counter we will write. Yes. So now 4-bit binary counter. How the counter will count? Now you have the idea. Now you think. Like simple, I can say the counter will be like 4-bit binary counter in the sense the count will be takes place from the value of 0 to 15. 4-bit binary counter. So that will count the clock pulses. Right. So now let me write the program how to write module binary counter. What is the input for counter? Any idea? So here binary counter, the input is clock, reset, and the Q is the output. The input is 2 inputs are there, clock and reset. The output is a Q, which is 4-bit actually. So 3:0. The register also will be 3:0. Always at passage begin. If reset is equal to 1, because initially we need to count. So I will say, as you know, the truth table of counter. Let me say, what is the truth table of counter here? What is the truth table for counter now? Truth table. Yes, truth table input clock I leave. For every clock actually will have Q. So clock is 1, then Q will be 0, 0, 0. Next clock is second clock cycle. We'll have 0, 0, 1. Next third clock cycle will have 0, 0, 1, 0. Next for fourth clock cycle we'll have 0, 0, 1, 1. Next for fifth clock cycle we'll have 0, 1, 0, 0. So like this it will go. So it will go on like this. Keep on. It will go in this way. It like this. Then finally we'll have the clock cycle number 15. We'll have all the values are 1, 1. Now you think how to write here.
Sir, 16.
Totally 6, 0 to 15. Oh, sorry, 1 to, okay, sorry, yeah, it's supposed to be 16. If I consider 0 means 15. Okay, now you tell me, how can I write here now? See, logic, you think, counter, it has to count. First, initially, I need to clear the counter, so it has happened already. Now what I should do? During the next edge of the clock, I should get as 1. What I should do now?
Add 1. Sir.
You should add this value, right? The 0, 0 with this plus 1 I should add, correct? So here I can say this is nothing but will become as previous value for this, correct? So 0 plus 1, if I add during next clock, I'll get 1. Okay, what next I should do? Again, with this I should add plus 1, then I'll get 2. Then again I should add plus 1, I'll get 3. So from this, what we can understood, for each and every from this number, I should add plus 1, I should add. So what is the statement will come now? Here, can I have an idea? What is the statement will come now?
Q equal to Q plus 1.
Yes, Q is equal to Q plus 1 will get. Because the Q is here, you can see, we written left hand side also, we written right side also. Means already we declared the Q as registered. If you declare the variable as a register, that can be used in left hand side as well as in the right hand side. That is very, very important here. You should have to keep. So this Q and this Q, don't get confusion because of uppercase and lowercase and all. So let me use uppercase only, because of else you won't get, you will get confusion. Okay, see 1 plus 1. Now automatically what will happen now? First initially reset is equal to 1, this will become 0. Next when reset is equal to 0, then the Q is previous value is 0, 0 plus 1, 1. The Q will become as 1. Next, during the next stage of the clock, what will happen? Again, this Q value is 1, 1 plus 1, 2. Then 2 plus 1, 3, 4, 5, 6, 7, 8, 9, it will go. Now you think, once it's reached 15, what will happen? Because you think this whole thing will work as one loop statement. Continuously it will execute. It will execute by like plus 1 plus 1 plus 1 till 2. But you think how you think it will count up to 15? Because we're not specified. How? Because Q equal to Q plus 1 only is given. Now you think I will reach, the Q will be reached as 1, 1, 1. Now you think like this. Q will be reached 1, 1, 1. Again, what will happen during the next stage of the clock? What will happen? That Q will become as 1, 1. Again, add with plus 1. Now this Q will become as what? 1, 0, 0, 0, 0. Like this will come. But whether it will reflect your output, we'll get like this. Is it correct?
It will be 5 bits, sir.
So yes, here it is 5 bit you are getting, but as you know, this Q is.
But we consider only 4 bit now.
4 bits. Yes. So what will happen? The system will do. It will truncate the MSB value.
0.
Yes, it will truncate this. The MSB will be truncated, so you will get 0. Will get. That is what the system will do normally. I hope you understood this. Yes. So automatically I get a 0. Then again go as 1, 1. So this MSB bits will get truncated. Because of left hand side and the right hand side, the size of the bit should match. That is very, very important. As I said earlier, left hand side and right hand side should match always. So we'll get like this. This is what I can call 4-bit binary counter, or sometimes we may call it as 4-bit binary up counter also, we can say. It is a up actually. It's a up counter also, I can say. Now can I give the idea what is the down counter? How can I write down counter now?
Starting from 1, 1, 1. And Q equal to Q minus 1.
Starting from 1, 1, 1, Q is equal to Q minus 1. If you think like that, you think now your idea is like this. You will get like this. Is it correct?
Yes, sir.
You will get 1, 1 is
Not
okay.
actually, sir.
Okay, as you are saying 1, 1, okay. Initially, okay, it's a good only. Okay, you initialize value as 1, 1, 1. But as a counter, you cannot fix value as 1, 1, 1 normally. Correct? You can clear the counter. You cannot fix the value. Is it right? The reset.
Sir,
what is the use of reset?
Preset.
Yes, you can do preset. You are saying you can do the preset also. Correct? If you are doing preset, all the values are 1, 1. If you are making now minus 1, you are making. Okay, 15, 14, 13. You will get. Now you come. Finally, you will get 0. Okay, last value is 1. You will get 0, 0, 0, 1 minus 0, 0, 0, 1. It is 0. Okay, I am getting. Now next what will happen? 0 minus 1 will come. What will happen now? Did you understood the question? What I said now? As the question they said 15, it is down count. Okay, 15, 14, 13 because minus 1 is there. So our last will reach 0. After again what will happen? 0 minus will come. 0 minus 1. It is a minus 1, correct? That's down counter. Again what I should get actually? After 0? Again I should get 15, correct?
15, sir.
Yes, again 15.
Yes,
So
sir.
yes, is there any idea how it will be? Very simple. 0 minus 1 is nothing but what? Minus 1. The negative number you will represent in the 2's complement form. So 2's complement of minus 1 is what? Plus 1 is this, correct? No? Plus 1 is this. 2's complement of this 1, 1, 1, 0 plus 1. Then this will become as
1.
yes. So what happened? 15. Yes, this is what the system will give you the 15. Again you get as 15. Automatically you get 2's complement number. So 15 will get for next to 14, 13. Like this only the system will work. Is it clear now?
Yes, sir.
Okay. Now can you tell me, for everyone, you are a little bit logical thinking you do. Same program, a single program, I need to write both the counter has to count up as well as down. Idea is like this. You have to write the counter. Yes, you can take us work this one. Right here, Verilog code. You try this. Verilog code for up down counter. I can call us up down counter. Up down counter. The logic also I'll say how it has to be. Simple. How it is to be in the sense. See, your counter is counting. Okay, up counter. Say example. I am counting. I'm writing randomly. I'm writing 0, 1, 2, 3, 4, 5, 6, 7, 8, 7, 6, 5, 4, 3, 4, 5, 6. See, it has to go like this. It is the up down counter. What happened here? The counter first, it is counter in up count till here. Immediately what happened? From this place to from this place, it started to down count. 5, 4. Again, it started to up count. I need to write in a single program. The single program it has to perform, it has to give the output like this only. Your counting number, it has to come like this. Can you try, everyone?
Yes, sir.
Yes, I hope you can try this work as your one assignment. You can consider this one assignment. Yes, you take that this is the one assignment. Okay. Next, the second assignment, what you will do? I want you to try the another one more counter called as BCD counter. These two I need you need to. So you try. If not possible, don't try or don't search in the net and all. So everything will get, but you don't do like that. Just get the concept with you. If you're not getting, then in the next class you can ask how it has to be. I want these two assignment you have to write by your own. BCD counter and this up down counter, binary up down counter. Still now, is there any other queries?